Good afternoon, students. In the previous lecture, we have seen the numerical on potential and we have seen the potential gradient. Yes, and we have established the relationship E is equal to minus del V. This we read it as gradient of a scalar point function, grade V, right? Okay. This is the relationship between the electric field intensity and the potential we have seen. Then one more useful relationship we got is in order to find out the magnitude of the electric field intensity, it is given by the rate of change of potential dV by dl, maximum rate of change of potential. This also we have seen, right? But this is the most useful form of relationship between the electric field intensity and the potential. This we have seen, right? So this how to read it? Del V or gradient of this V, grade V or gradient of V, right? So we will read it as minus grade V, right? This gradient operator is this one, gradient operator, right? Is a gradient, here we call it as gradient operator. This is a del operator actually, but we call it as a gradient operator here in this case. Also we can read it as gradient of V, gradient of V, but usually we will be using this, right? Okay. In today's lecture, just we will see the potential gradient in different coordinate systems and also few numericals on the potential gradient. We'll see, right? Okay. Yes, del V. This formula, general formula, right? Del V is equal to summation of, sorry, yes, fine. Del V is equal to summation of 1 by H1, 1 by H1, dou V by dou U into AU. This has been expanded here. You can remember this, but we don't. This has been expanded. No need of this also. Easily, I will tell you how to remember this. For divergence, this kind of formula is required. For here, it is not at all required. Just observe here. Del V. We know the relationship E equal to minus del V. Minus you should not leave. Only we are talking about the gradient operator del V. So what is del V in Cartesian coordinate system? It is nothing but dou V by dou x into Ax, dou V by dou y into Ay, dou V by dou z into Az, right? Okay, and gradient of a scalar point function is a vector, so Ax, Ay, Az are coming into picture, right? So similarly, how to write in cylindrical? Just I will tell you, just observe here. Dou V by dou rho into A rho, dou V by dou phi into A phi, dou V by dou z into Az. What are the scale factors? 1 rho 1. So in the denominator you can observe here, I can write it here, 1 by 1, 1 by rho, 1 by 1. In the denominator you observe here, 1 rho 1. These are the scale factors. Here the scale factors are 1, 1, 1, H1, H2, H3. Here the scale factors are 1, rho 1. Here the scale factors in spherical is 1 r sin theta, right? So how to write in spherical? Del V is equal to dou V by dou r into AR, dou V by dou theta into A theta, dou V by dou phi into A phi. So 1 by 1 scale factor, first scale factor, second 1 by r, 1 by r sin. Just observe it, 1 r sin theta, right? Easily you can write. No need of this formula. This is not required, right? Okay. Then for divergence we have seen. Okay, we'll solve. Then okay, we'll see it later. We'll solve with the numerical. Given the potential field is given, this potential field is given, it is equal to 2x square y minus 5z. Because v is a function of x, y, z, it can be located anywhere in the field, right? Already in the derivation we have seen v is a function of x, y, z. It may be located anywhere in the field, right? So they have given this equation and a point p of minus 4, 3, 6. And we wish to find several numericals at point p, right? Find the potential v, yes, the electric field intensity E, the direction of E, the electric flux density D, and the volume charge density rho V. All these things we have to calculate. Yes, we'll solve it. V is given 2x square y minus 5z. And point P, this is at point P, so minus 4, 3, 6. First what they have asked, find the potential at this point. At this point, find out all these things. Potential, electric field intensity, right? So first, part A, potential at point P. So V at point P. Substitute point P is minus 436. This is x, y, z. Substitute the value of x, y, z in this. So and calculate. That will be the potential at point P. 2 into x square, that is minus 4 whole square into y. Y is 3. Minus 5 into z is 6. Right? So write down how much you will get. So 2 into 4 square, 16 into 3. Y is 3, right? Yes. So I'm getting 96. 96 minus 5 into 6. 5 into 6, 30, right? 5 6 are 30. So I'm getting 66. 66 volts. So the potential at point P is 66 volt. First one is over, right? We have calculated this. Then we'll see the electric field intensity E at point P. So we want electric field intensity E at point P. So we want to calculate this, right? So we know the relationship between E and V. E is equal to minus del V. So we know this relationship. So first, just observe the potential. It is in Cartesian system, right? Cartesian coordinates are coming into picture. So we will write down the formula del V. So del V is equal to, in Cartesian system, dou V by dou X into AX plus dou V by dou Y into AY plus dou V by dou Z into AZ. So we are finding out only del V, but this minus sign, while writing E, you have to take care of this minus sign. First we are calculating only del V, right? Okay. So what is V is given? First we have to differentiate with respect to X. With respect to X means just observe 2y is constant, right? So differentiation of X square, right? 2 to the 4x, right? So 4xy I will get, right? So 2y will be coming, then differentiation of x square is 2x, 2 to the 4, right? 4xy. So this will be 0. Then next into ax, then differentiate with respect to y. So 2x square is constant. So 2x square I will be getting. Differentiation with respect to y is 1. Then this will be 0. Then differentiate with respect to z. So this will be 0 because this is constant. With respect to z means, so with respect to z means minus 5 I will get. So sorry, into ay I have to write. Then next with respect to z, minus 5 I will be getting into az. Right, this is del v. So this is E at point P. Let me call it as EP because E at point P, right? E at point P is equal to minus del V, whatever we got, you write it. 4xy. Let me take this minus sign outside, into AX plus 2x square into AY minus 5AZ. So substitute the value of x, y, z, then I will get E at point P. This is simply E, right? So E at point P I want. So substitute the value of x, y, z. X is minus 4, y is 3, z is 6. So substitute and write it. So I'll calculate the first term. So minus, let me keep it, or else I will be taking, okay, no problem. Or else we can keep it outside. Okay, I will be keeping it outside, no problem. So 4 into xy. 4 into x is how much? Minus 4 into y is 3. So I am getting it as minus 48. Minus 48 ax plus 2x square. 2 into x square is 4 4 just 16. So 32. So 32 ay minus 5 az. So multiply this minus and write it. 48 ax minus into plus minus 32 ay. So plus 5 az. So E at point P is this much volts per meter. So part B is also over, right? Next. This is over, potential at V, the electric field intensity E. Then next, the direction of E vector. We want the direction of E vector. So part B we have E vector, right? So we want the direction of E vector. So already we have E vector at point P, right? So next, so the direction of E vector, let me call it as AE vector, right? Because the vector directed along the field. So unit vector, they are asking the direction of E vector means they are asking the unit vector in the direction of the field. So AE vector at point P we will take, right? So the E vector at point P divided by its magnitude, right? So do it. So 48 AX minus 32 AY plus 5 AZ divided by root of 48 square plus minus 32 whole square plus 5 square, root of this, right? 5 square. So we'll divide and simplify and write it. So first denominator I will be calculating. So root of 48 square plus 32 square plus 5 square, that is 5 5 is 25. So this root of something I will be getting it as, so I will be writing here somewhere here 57.905, this denominator. So I am getting it as 57 point. So we will divide and we will write it 48 divided by 57.905. So I am getting it as 0.829 ax minus 32 divided by 57.905. So 32 divided by 57.905. So I am getting it as minus this minus sign as it is 0.552 ay. Then last term 5 divided by 57.905. So 0.086 plus 0.086 az. So this is the unit vector, right? So you can check it 0.829, right? 0.55, 0.086. This is over, right? The next, the electric flux density they have asked D. So part D, we know the relationship between D and D. D is equal to epsilon naught E, right? So D is equal to epsilon naught E. Is it fine? Okay, there are two ways of doing it. D at point P, if I want, I have to take this E vector. If it is general one, I have to take this, right? So D equal to epsilon naught E. But both are one and the same, but they have taken xy, in terms of xy means they have taken this as E, right? They have not taken this. Both are one and the same. We have substituted the values of xy because they have asked to find out the numerical values at point P, right? Okay, but we will write the general thing only. So E is this one, I will take it, right? Okay, fine. So multiply, what is epsilon naught? 8.854 into 10 power minus 12, I have to multiply. So I will multiply 8.854 into 10 power minus 12 for this, and I will write it, right? Or else 10 power minus 12, they have taken it as pico, so let me take it outside, right? Just I will multiply 8.854. So, and minus sign I will multiply. So minus 4xy, right? So multiply 8.854. 8.854 into 4. So I am getting it as minus 35.416 xy into ax. The next minus into, so this one, sorry, minus into plus, once again minus. So multiply 8.854 into 2. So I am getting it as 17.708. So x square as it is, x square into ay. Then next minus 5, then minus into minus plus 5, multiply by 8.854 into 5. So I am getting it as 44.27 az. But it is 10 power minus 12, right? 8.854 into 10 power 8.854 is multiplied 10 power minus 12, right? So coulomb per meter cube, right? They have expressed it as pico, 10 power minus 12 coulomb per meter cube, right? And you can substitute the values of xy for this, so that I will be getting D at point P, right? Okay, you can substitute and write it. So I will get D at point P, D at point P. Substitute the value of xyz and write it. So this is general D vector. If I want at point P, we will substitute and write it. So they have not given a book, but we have to do it because they are asked to calculate numerical values at point P, right? So minus 35.416 into x. X is minus 4 into y. Y is 3. So I am getting it as 424.992 ax minus 17.708 x square. What is x? X is 4 square, that is 16. So 283.328 ay plus 44.27 az into 10 power minus 12 coulomb per meter cube. So this is D at point P. this one, right? This is a general vector. Then next, the last one, they have not given here, don't try to verify. I have substituted the value of x, y, z, right? Then next, and the volume charge density rho v. Then how to calculate rho v? We know the relationship d equal to, what is the relationship between this volume charge density and, right? How to find out? Divergence of d vector, del dot d equal to rho v. So d vector we have found out here, general vector, right? So we want to find out the divergence of d vector, so that we are finding the volume charge density rho v. So we will write it like this: rho v is equal to del dot d vector. So just I will write the d vector here once again. General d vector I will be taking, not at point P. This is at point P. So general vector I have to take, because I want to apply the divergence operator on this. So I will be taking the general one, minus 35.416 xy into ax minus 17.708 x square into ay plus 44.27 az into 10 power minus 12 coulomb per meter cube. Yes, this one I have taken, right? Okay. Next we want this, observe here, ax, ay, az means we want divergence in Cartesian coordinate system. So del dot of d vector, what is the formula? Divergence of vector is a scalar quantity or vector quantity. Gradient of a scalar is a vector, divergence of vector is a scalar quantity. Means I will be getting this dou by dou x of dx plus dou by dou y of dy plus dou by dou z of dz. Yes, this formula is correct, or else you have to verify that formula. If you don't know, del dot of d vector in Cartesian coordinate system is 1 by, what is that formula? 1 by h1 h2 h3 into summation of dou by dou u of h2 h3 du. If you expand this and substitute, so h1 h2 h3 are 1 for Cartesian, so this will be 1 by 1, leave it. So dou by dou x of d, correct, right? Dou by dou x of dx, dou by dou y of dy, dou by dou z of dz. So what is dx? This is dx into ax, dx into ax, next dy into ay, this one is dy, then next dz into az, right? So do 1 by 1, then add all the three, right? Okay, first with respect to x, dou by dou x of dx, this is dx, right? So minus 35 into 10 power minus 12, we should not leave it. So 10 power minus 12 I will be taking outside, so we should not skip this, we will take it. So first integrate and differentiate with respect to x. So what I will be getting? Minus 35.416 with respect to x means y is constant, right? So y, right? Minus 34.416 with respect to x means y is constant, it is written as it is, plus next second term differentiate with respect to y, dy, this is dy, minus is there, so this minus, let me say it will come or not, let me check it. With respect to y means this will be 0, because only dy is having x term, right? This is constant, so this will be 0, second term will vanish. The next come to the third term, so this is once again dz is constant, so this will be 0 once again. So what I am getting? Minus 35.416y, right? This is del dot of d vector, but what I want, rho v, right, at point P. So what is point P? P is minus 436, minus 436, substitute the value of the x, y, z, so substitute the value of y here. So rho v is equal to del dot of d vector, that is equal to minus 35.416 into y. What is y? Y is 3, so just multiply, so I will be getting 35.416 into 3, so 106 minus 106.248. Yes, we should not leave, I told you. So this one into 10 power minus 12, right? 10 power minus 12 is there, so into 10 power minus 12, so this one into 10 power minus 12, or else 10 power minus 12 is nothing but pico, right? Coulomb per meter cube, charge per unit volume, right? So coulomb per meter cube, right? So rho v is equal to minus 106.248 pico. 10 power pico is 10 power minus 12 pico coulomb per meter cube. So you can verify here. Is it right? We have calculated all the values, numerical values at point P, right? The next, we'll move to the next numerical. The electric field intensity is negative gradient of scalar potential. This is not required, we know it. Problem starts here. Find the electric field intensity E at the point P of 0, 1, 1 if V is given. This, just observe, V is given e to the minus x sine of pi y. This is given in Cartesian system. No need to tell this, it is in Cartesian, right? Just by looking at this, we have to identify it is given in Cartesian. Just observe this, r theta is coming, this is theta. V is equal to E naught r cos theta. So this is in spherical. No need to give, it is in spherical, right? Just by looking at this, we should understand it is in spherical system. So it is asked to find out E. So we know the relationship between E and V. E is equal to minus del V, right? So part A. So V is there, V is given, V is equal to E naught e to the power of minus x sine of pi y by 4. So I want minus del V, right? So first we'll calculate del V, then we'll so first calculate del V. So write down the formula in Cartesian system. This is in Cartesian system, right? Rectangular coordinate system or Cartesian system. So write down the formula. Gradient of a scalar point function is a vector, right? Dou v by dou x into ax. It is a vector. So append the vectors dou v by dou y into ay plus dou v by dou z into az, right? At point P they are given. So at point P means we'll take this 0, 1, 1. Well, we'll substitute later this x, y, z. We'll substitute later. So del v is equal to. So differentiate this quantity with respect to x. So E naught sine pi y by 4 is constant, right? E naught sine pi y by 4 is constant. So differentiation of e to the power of minus x. So minus e to the power of minus x. This minus sign I have taken here, right? The next, come to the second term into ax. I should not leave this vector, right? The next, dou with respect to y I have to differentiate. So y is, so which is constant? E naught into e to the power of minus x is constant. So differentiation of sin x is cos x. Cos of pi y by 4. So with respect to y, right? So pi by 4 will come, right? Pi by 4 you can take it here also, no problem. The next, third into ay plus with respect to z I have to do. So everything is constant, it means this will be 0, right? Then next we'll substitute. So I want e equal to minus del v, right? So del v, will substitute the value of x by z here and we'll write it. Is it fine? So E naught can be taken out. E naught can be taken out. E naught is taken out. So this minus sign of pi y by 4 e to the power of minus x. So what is the value of y? Y is 1. We have to substitute y equal to 1 and x is 0. Right? This will be 1. Anything to the power of 0 is 1. Right? So I should calculate this. So substitute the value of y and calculate. So my calculator is in degree mode. So what I will do? Instead of pi I will take 180 degree. So y is how much? 1. So 180 by 4. Sine of 180 by 4. So sine of 180 divided by 4. So pi is 180 degree and y is 1. So by 4. So I am getting it as 0.707. And this minus sign I have to take into consideration. Right? Okay. Minus 0.707. This e to the power of x is what? 0. So this will be 1. This quantity is 1. So leave it. So and write it ax. Then next e naught is taken out. So plus what I am getting, we'll see. Yes, once again x is 0. This will be 1. So this we will see, and we will multiply with pi by 4 later on, right? So cos of y is 1, cos of 180 degree divided by 4, 180 divided by 4. Because my calci is in degree mode, so I am pi, I am substituting it as 180 degree. So I am getting 0.70, sorry, okay, 0.707, but pi by 4 is there. I will multiply with pi by 4 and I will write it into pi divided by 4. So I am getting it as, I am multiplying this with pi by 4, right? I have done it. So I am getting it as 0.555, right? Ay as it is, right? Is it fine? Okay, check it. But this is del v. What is E? E is equal to minus del v, right? So E is equal to minus del v. Whatever we calculated is del v. So just multiply minus for this and write it, right? So E naught is outside. So minus into minus, this will become plus 0.707 AX. Then minus into plus minus 0.55 AY. I hope you got it. So this is volt per meter. Just you can compare with this, right? We're getting same answer. So part B also same way, but this is given in spherical. So del V we have to do in spherical, right? Part B will take up V is equal to E naught R cos theta. This is in spherical, right? So we know that E is equal to minus del V. So first we have to find out del V. It is in spherical coordinate system, right? So dou V by dou R into AR. So we know the scale factors, 1 R sin theta. These are the scale factors, right? H1, H2, H3. So 1 by 1, yes, leave it, no need to write. The next scale factor is 1 by R. 1 by R will come into picture, next scale factor, right, in the denominator. So dou V by dou theta into A theta. Then third scale factor is R sin theta. So 1 by R sin theta into dou V by dou phi into A phi. Right? So observe the denominator 1 R sin theta. These scale factors are coming in the denominator, right? So other things R theta phi. It is fine. So calculate this. So with respect to R we have to calculate, right? So first one differentiate with respect to R. So E naught cos theta is constant. E naught cos theta. Right? This will be 1. So into AR plus 1 by R into with respect to theta, right? So with respect to theta means E naught into R is constant. E naught into R is constant, right? Differentiation of cos theta is minus sin theta, right? So into A theta. Then plus 1 by R sin theta as it is. Then next differentiate with respect to phi. So this is constant, so this will be 0. Right, into A phi. So it is 0, anyhow no need to write A phi also, it will be 0 only, leave it. So del V is equal to, so E naught can be taken out, right? So cos theta into AR, so this RR will get cancelled, so minus sign can be taken here, minus E naught is taken out, E naught is taken out, so minus sin theta into A theta, right? This will be 0. Then next substitute the, yes, they have given at this point P of 0 1 1, at P of 0 1 1, this is x y z, but what I want here, theta I want. So we know the relationship R is equal to under root of x square plus y square plus z square, and theta is equal to what, cos inverse of z by r. So cos inverse of z by r. So r I want, so I will calculate r also because z is given, right? So first calculate r so that I can calculate theta. So first calculate under root of x square is 0 square is 0, leave it. Then y square, it is 1 square is 1 plus z square is 1 root. So I am getting 1.414, right? So cos inverse of z by r. Z is how much? 1. and R is 1.414. So calculate this. So shift cos inverse of 1 divided by 1.414. 1.414. So I am getting it as theta is equal to 44.99 degree. I can take it as 45 also, right? So 44.99 degree. So substitute the value of theta here. So del V is equal to E naught into yes cos of 44.99. So I am getting it as 0.707. 0.707 AR minus, instead of cos, sine of 44.99. So it is 0.706, 0.7068 theta. But what is E? E is equal to minus del V. So minus of this, right? So E is equal to minus. So just minus del means just multiply minus for this. So E naught into, so minus 0.707 AR minus into minus, this will be plus 0.7068 theta volt per meter, right? So you can just verify AR and D theta. Is it fine? Volt per meter. 0.706707, right? Based on the fractions what we are taking, right? Both are over. Next, this I will leave it to you people only. I hope you will do it. An electric potential is given by V equal to 60 sin theta by R square. Find V and E at point P. V at point P means this is R theta phi is given, right? R theta phi. So this is given in which system? Spherical coordinate system. The formula of in spherical coordinate system, this is the formula del V, right? So V at point P, substitute the value of R theta phi, you will get V at point P. You will get it. Find it out. So it is they have not given here. V at point P they have not given. So you calculate. Just substitute value of R theta and phi, that will be Vp. Then find E. E is equal to minus del V. You know how to find out del V. So del V, this is the formula. Do it and finally you will get this. This is minus. Minus should be taken in first, find out del V, and so multiply minus 1 for that. So that I will be getting this. I will leave it to you people. Homework. Right? I hope you will do this. Or else if time permits at the end of the class I will give some time to solve. Okay, we'll see it. The next, we'll move to the next problem. Okay, given the potential field in cylindrical coordinates, this is given in cylindrical coordinates, right? 100 by z square plus 1 into rho cos 5 volts, and the point P is given. This also in cylindrical, rho equal to 3, phi equal to 60 degrees, z equal to 2 meters. Find the values at point P. For potential at point P means several numerical values at point P, potential at point P, E at point P. How we done for first problem? Then this E, then what is this dV by dN? In the derivation we have done this. We will see when we come to this part E, an vector, rho v in free space. We will see all these things, right? I think this is the last problem of today's class. Okay, part A we will take up. V is given and rho phi z is given. So part A, find out V at point P. So potential V at point P. So point P, what is point P? So let me write down point P here. So it is 3, 60 degree, rho phi, z is 2. This is rho phi z they are given. This is point P at rho equal to 3, phi 60 degree, z is 2 meters, right? So substitute the value of rho phi z here in this and write it. That's all, right? So directly I will do it. 100 into rho square. Rho square means 3 square. 3 3 is 9 into cos phi. Cos phi is how much? Phi is 60 degree. Cos 60 degree. Cos 60. So close the bracket. Divided by 100 into rho into cos phi done. Divided by z square plus 1. What is z? Z is 2. 2 square is 4. 4 plus 1 is 5. Right? Divided by 5. So 90 I am getting. Somewhere I have made a mistake. Please check it. Because they have given 30. Somewhere I have made a mistake. Let me check it. 100 into rho is how much? Oh, 3. Sorry. 100 into 3. I have taken 9. 100 into 3. 100 into 3 This I have taken it as 9 in the calculator. 100 into 3 cos of 60 degree, right, divided by 5. So I am getting 30, same as this, right, 30 volts. Or else you substitute and write it. Directly I have done. I hope you got it. So 30 volt. Then part B, find E vector. Yes, E vector at point P we want to find out. We will see, right? So this is given in cylindrical coordinate system. Cylindrical coordinate system, right? So we know the relationship between E and V. E equal to minus del V. First find out del V, then multiply minus for that, right? So del V in cylindrical coordinate. First write on the formulas. What are the scale factors? 1, rho 1 is the scale factor in cylindrical coordinate system. H1, H2, H3. So write down the formula, dou V by dou rho into A rho. So 1 by 1, the scale factor is over. Next, second scale factor is 1 by rho, 1 by rho. Then dou V by dou phi into A phi. Then next, second, third scale factor is 1, 1 by 1, right? Then dou V by dou Z into Az. It is very easy to write down the formula, right? In all the coordinate system, which is very easy. No need to remember that general formula, right? Okay. This is very big. Okay, one by one we will do. First I will do this. Call this as equation 1. First we will see dou V by dou rho into A rho. So first term dou V by dou rho, just I am taking first term. This is first term, then second, then third. Right? We'll see. First I will do dou V by dou rho. So dou by dou rho of what is V? 100 rho cos phi. 100 rho cos phi divided by z square plus 1. Yes, with respect to rho means 100 cos phi by z square plus 1 is constant, right? This is constant. So differentiate with respect to rho is 1. So I am getting this. Fine. First term is over. Come to the second term. 1 by rho into dou v by dou phi. 1 by rho into dou v by dou phi with respect to phi, right? So that is equal to 1 by rho into dou by dou phi of this v, that is 100 rho cos phi. If it is a very big term, better to split it and do it separately, right? Z square plus 1. So with respect to phi, so with respect to phi means 100 rho by z square plus 1 is taken out. 100 rho, yes, this rho will get cancelled. This rho and this rho will get cancelled. So 100 by z square plus 1. So differentiation of cos phi is minus sin phi. So minus is taken here. So sin phi. So second term, this entire thing we have calculated. Then come to the third term with respect to z. Yes, so I'll be going to the next slide. So dou v by dou z. Right, dou v by dou z. So dou by dou z of what is this v? 100 rho cos phi divided by z square plus 1. Okay, with respect to z, yes. So 100 rho cos phi is taken out. So can I write it like this? Dou by dou z of z square plus 1 whole inverse. I will be taking it to numerator, right? Can I write it? Z square plus 1 whole inverse. So 1 by something, right? So differentiation of x to the power of 1 and x to the power of that I want to apply. Let me check it, right? If I am making any mistake, please unmute yourself and speak to me, right? Just we'll see. 100 rho cos phi x to the power of 1 n x to the power of n minus 1, right, into minus as it is z square plus 1 nx to the power of n minus 1 means minus 2 I will get. So since with respect to z means I am getting 2z. I hope this is correct, right? This will come in the denominator minus this minus sign as it is 100 to 200, right? 200 100 into this 2 100 into 2 200 rho cos phi, this z, yes, rho cos phi into z, rho cos phi is written, then this z is written divided by z square plus 1 whole square minus 2, right? So I hope this is correct. Yes, Yes, we'll substitute in equation 1 implies. Equation 1 implies. So del V is equal to first term is 100 cos phi by z square plus 1. 100 cos phi by z square plus 1 into arrow. Then second term is here 1 by this entire thing, right? So minus 100 sin phi minus 100 sin phi by z square plus 1 into a phi. Yes, correct. Then third term dou v by dou z into az. Dou v by dou z is here minus 200 rho z, rho into z I will write first, then cos phi divided by z square plus 1 whole square into az, right? So but what we want to calculate, E at point P. So E is equal to minus of del V, but at point P, what is P? P is 360 degree and 2, right? Yes, so let me write P here once again for my reference. 360 degree, 360 degree and 2. This is rho, this is phi, this is z. Substitute here, right? So that it will be very easy for you. So first I'll substitute del V at point P. So I'll substitute and write down at a time. So 100 into rho is how much? Sorry, 100 into cos phi. Cos phi is how much? 60 degree. Cos 60. 100 into cos 60 divided by z square plus 1. Z is 2. 2 square is 4. 4 plus 1, it is 5. It is 5. So I am getting this as 10. First one, 10 arrow. This entire thing after substitution. If I am, please correct me if I am making any mistakes, please, right? Okay, then I'll substitute for value of phi and z here, and I'll calculate this one also. So 100 into sin phi. Sin phi is how much? 60 degree. Divided by z square plus 1. Once again 5 only. Z square is 2. 2 square is 4 plus 1 5. So calculate this. So this minus sign is there. Write down minus 17.32 a phi. Then this minus sign, we'll write it as it is. Then we will calculate this numerator 200 into rho. Rho is 3 into z is 2. Rho into z into cos phi. Cos phi is how much? Cos 60. So divided by z square plus 1. So z is how much? So 2 square plus 1 5 square. 5 is 25, right? So I am getting it as 24. This is at point P, at P. So I want E vector, right? So EP is equal to minus del V. So EP vector is equal to E at point P is equal to minus del V. So multiply minus for this and write down minus 10 arrow, minus into minus plus 17.32 A phi, minus into minus plus 24 AZ volt per meter. Just check it. Minus 10 arrow plus 17.3 Fi 24 AZ, right? This is over. Second one. Volt per meter. Then next part B is over. Next part C. Yes. Part C, how to do it? Just observe here. They have asked magnitude of E. Already you have E at point P. Part C is just take the magnitude. E is equal to magnitude of vector E at point P. Just take the magnitude of this, under root of this, right? So under root of 10 square plus 17.32 square plus 24 square. So under root of 10 square plus 17.32 square plus 24 square. So root of this I am getting it as 31.24 volt per meter. So sorry, this I should not write it as a vector because it's magnitude, right? So this one is correct, volt per meter. So just check it, 31.24, right? 31.24 volt per meter. So this is over. Next, there was dV by dN. So how to calculate this? Let me check it. There was dV by dN. So in the derivation, if you remember, let dV by dN is equal to something we have done, right? dV by dl max. dV by dl max, I think. dV by dl max, if you remember. Yes. We in the derivation, we have assumed let dv by dl max, it should be reversed like this. Let dv by dl max is equal to dv by dn we have done. Then what is this? This is equal to E, right? So dv by d1 dn is equal to E. What is E? In the previous case you have done 31.24, 31.24 volt per meter. 31.24 volt per meter. Got it? In the derivation, we have assumed let dv by dl max is equal to dv by dn, and that is dv by dl max is nothing but E, right? So E is equal to dv by dn. So this E already we have calculated. So this is also over. Part D 31.24. So dv by dn, this is over. Next we will see part E, an vector. Yes, what is this an vector? If you remember that formula, just let me try to recollect that. E vector is equal to, as far as I remember, I'll try to recollect. So an vector they asked. So E vector is equal to minus, I think, yes, dv by dl max into an. I think this is correct. Yes, in the derivation it had come, right? So minus sign dv by dl max into an. I hope this is the formula, right? Okay, we know the E vector at point P, we have calculated. We know dv by dl max, it is nothing but dv by dn. Here we know. So if we want an, so an is equal to E vector. So we will write what is E vector. At point P we will take, yes, we will take E vector at point P. So already we have E vector at point P. So this I will be writing E vector minus 10 arrow, minus 10 arrow. I am writing LHS plus 17.32 A5 sorry, this one minus 10 arrow plus 17 minus plus, correct, right? Yes. Then next 24 AZ is equal to minus this minus sign. What is dv by dl max? It is dv, it is nothing but 31.24, 31.24 an. Now calculate an vector is equal to this entire thing divided by minus 31.24. So I will divide and write. So minus 10 minus and this minus, it will be plus, right? 10 divided by 31.24. So I am getting it as 0.32, 0.32 arrow. Then next plus is there and this is minus. So it will be coming minus 17.32, 17.32 divided by 31.24. This 17.32 divided by 31.24. So I am getting it as 0.55. 0.554 A5. Then coming to the third term, plus 24 divided by minus 31. So it will be minus 24 divided by 31.24. So I am getting it as minus, and as it is 0.768 AZ. Right? This is the unit vector. So don't write any units here. Just check it. 0.32 arrow, 0.32 arrow, 0.55 minus 0.55 A5. Then next minus 0.77 AZ. Right? This is correct. So this is over. Yes, this is not over till here. This one we'll see. Then rho v in free space. F. You have asked to calculate rho v in free space. What is rho v in free space? So we have all the data. Then how to calculate rho v? We have v. Then for that, what to do? Rho v. Right? We have done in the previous problem. So rho v can be found out by using, yes, anything is possible. Let me check. It's not possible from all these things. Once again I have to make use of divergence. What? Okay, fine. Let me. Rho v is equal to del dot of d vector. This we can do it. What is d? We have to find out once again. So we have E vector, but this is at point P. But I have to take the general vector, means this one I have to take. E equal to minus of this del v, right? Everything this should be. Then I have to take divergence. It is very big and complicated also. Okay, I'll see time permits or not. 323, 232, 330. Okay, just I'll give the hint. You try it. If you are not getting, just let me know. Rho v, how to calculate rho v in free space, I'm telling, right? So rho v is equal to del dot of d vector, right? Sorry, why I'm going backside. Okay. del dot of D vector. What is D? D equal to epsilon naught E. So don't take this E vector at point P. Write down, take the general vector, right? So how to take general vector? This is E vector at point P. So I want E vector at without at not at point, means this I have to consider 100 row this one, and so E minus del V means minus of this plus minus. So this will be E, multiply epsilon naught for this, right? Then apply the divergence. This is in which system? This is in rho phi z, means the cylindrical coordinate system, right? So apply it. After doing, you will get rho v, and it should be minus 234.4 picocoulomb per meter cube, right? I hope you will try it. I hope you got it what I told. Yes. So first first find out D equal to epsilon naught, then write down the del dot of D vector in cylindrical coordinate system formula, right? You write down that formula in cylindrical coordinate system, then you solve it. That will be your rho v. So it turns out to be minus 234 picocoulomb per meter cube. So I'll stop here only. It's already 324, right?